Motion planning is a term used in robotics for the process of finding a path from a start point to an end point. Rapidly exploring random trees, also known as RRT, is a key algorithm used in robotic motion planning.
The basic algorithm proceeds by sampling points at random and connecting them to a current graph. At every iteration, the system generates a random point in the configuration space and checks if it is in the free space. The algorithm then finds the closest node from the current tree and generates a new node by moving in a straight line between the current node to the newly randomly generated point. Here is the individual impact. In a 2014 research paper titled Analyzing the Effects of Human-Aware Motion Planning on Close Proximity Human-Robot Collaboration, researchers from MIT conducted an experiment in which participants worked with a robot to perform collaborative tasks. Participants worked with an adaptive robot incorporating human-aware motion planning. A database of robot motions was computed for every possible combination of human and robot actions using the RRT algorithm. This algorithm contributed to the implementation of the new robot human-like partner. This robot exposed the participants to their first successful human-robot interaction.
Its impact can be measured on organizations as well. The Jet Propulsion Laboratory at NASA used an RRT variant for path planning while designing the risk-aware Mars rover operation tool, a software to make the job of rover operators easy and to identify risks faster and more reliably. The 2015 paper titled Risk-Aware Planetary Rover Operation, Autonomous Terrain Classification and Path Planning uses a machine learning-based terrain classifier to create safety maps of the upcoming terrain. The RRT algorithm is run on these maps to manage obstacles, terrain types, slope, and wheel placement. This generates multiple optimal paths for the user to choose from. As the paper explains, the physical parts such as the wheels are the most likely part of the rover to break early, so the improved path planning of the RRT is speculated to increase the life cycle of rovers.
The RRT algorithm's impact on society can be seen in various areas. RRT algorithms have been implemented in many different autonomous vehicles, including self-driving cars, planetary rovers, and UAVs. The backbone of the motion planning technology for many of these autonomous vehicles is the RRT algorithm. The article titled Development of Flight Path Planning for Multi-Rotor Aerial Vehicles mentions the RRT algorithm's use in UAVs, which are used in military strategy, disaster relief, and exploration. The article mentions how the algorithm is used to randomly generate potential flight paths by generating collision-free waypoints. Finally, it is important to note that from 2009 to 2015, Google invested nearly $1.1 billion into autonomous vehicle technology. As the importance and relevance of autonomous technology continues to grow, so will RRT's impact on society.